When somebody talks about GitOps, the first association that most of us have is either Argo CD or Flux. But what if I say GitOps at scale? Are you still thinking about Argo CD or Flux? Or is there a potentially better solution? Let's check it out. Let's see how we can do GitOps at scale, at potentially huge, massive scale with many clusters. Both Argo CD and Flux are focused on giving us a mechanism how to synchronize a Git repository with a cluster. We can, of course, use both of those tools to synchronize a Git repository with multiple clusters, or to synchronize multiple Git repositories with many clusters and many other different variations, but they were not designed to work in multi-cluster setup. That does not mean that we cannot use those tools to manage resources in many different Kubernetes clusters. Of course, we can, but that was not the primary focus, the main focus behind the design of those tools. Rancher Fleet, on the other hand, is designed to do just that. It allows us to manage resources in up to 1 million clusters. Now, I haven't had an opportunity to test it out in million clusters. I doubt that anybody did. I doubt that even creators of Fleet tested it in million clusters. But what I can tell you is that it is pretty obvious that Rancher Fleet works fairly well with many clusters. It can work with one cluster, but then that would be questionable choice. But the more we scale that setup, the more clusters we have, the more we see the benefits of using Rancher Fleet instead of other tools to manage the resources in all those clusters. So let's explore Rancher Fleet and see whether it's really that good, whether it really delivers on the promise, what are the pros, what are the cons, and so on and so forth. But before we do just that, let me give you a quick warning. I will not explain in detail what is GitOps. I will assume that you already know what it is, and if you don't, then you should pause this video and check out this one. This is where I explain what GitOps is, what GitOps isn't, and so on and so forth. Similarly, I will not compare it with Argo CD or Flux. I will assume that you are already familiar with those. If you're not, then there are videos for those two as well. Check them out. If you are interested, I can create a separate video that compares the three, Rancher Fleet, Argo CD, and Flux, but that is not the subject of this video. Right now, what I really want is to show you how Rancher Fleet works, and later on in some other video, I might compare them or no, and whether I will do that or not depends on you. So please let me know in comments whether you would like a comparison between those three. And the demo with the showcase of Rancher Fleet starts right now. We could use Fleet to manage resources in a single cluster, but that's not what we're going to do today. If that's what you need, then go for Argo CD or Flux. They exist longer, they're better supported, they have more contributions, wider user base, and so on and so forth. Rancher Fleet shines at many clusters at scale, and that's what we are going to do. Actually, in this demo, I will not run it at scale. I will not run it on 100 or 1000 clusters. Instead, I will have 4 clusters. That will be more than enough to show you the benefits, the pros and cons of using Fleet, and you should be able to imagine how those 4 scale to 40 or 400 or 4000 or even more. One of those 4 will be the management cluster. That's where Fleet controller will be installed. That's the one that will manage all the other clusters. And it will also manage itself, so we will be able to manage that cluster using GitOps principles with Fleet, but also to manage all the other clusters. The second one will be a simulation of a development cluster, and then I will have 2 production clusters, production 1 and production 2. To make things more interesting, I will run those clusters in different providers. The management cluster will be GKE in Google Cloud. Development cluster will be Civo because it is extremely fast and cheap. And then I will have one production cluster in AWS and another one in Azure. AWS will be EKS and Azure will be AKS. Now, if you want to follow along and reproduce what I'm doing, you do not have to use those 4 providers. You can run everything in one provider. The logic is the same. Fleet does not really care whether you're running it here or there. As long as you have more than one cluster, you should be fine. And speaking of reproducing what I'm doing and following along, all the commands and the references to the repos with all the manifests are in a gist, and the link to the gist is in the description of this video, so go and check it out. The only thing that I did in advance was to create those 4 clusters. I did not want to bother you with the instructions how to create a Kubernetes cluster, especially since I do not know which provider is your favorite. So 4 clusters are already up and running, and I created environment variables that contain the path to kubeconfig for each of those clusters. There is kubeconfig man for management cluster, kubeconfig dev for development cluster, and kubeconfig prod 01 and kubeconfig prod 02 for production clusters. And that's about it. Those are all the steps that I did in advance, and everything else that I will do is inside of this video, so let's get going. Let's set up Rancher Fleet and see how it works. And to set up Fleet, we need to start with the management cluster. That's the first one we need to install, and the rest we'll get to that. I will try to go fast through the setup process because I want to get to the user experience of Rancher Fleet as fast as possible. First thing I will do is get the name of the management cluster, and then I'm going to retrieve certificate authority data. And I will also retrieve the address of the server of the management cluster. I do not need those 2 things right now, but I will need them later when I jump into the section of setting Rancher Fleet agents. To be on the safe side, I will confirm that the server and the certificate are indeed working, that they are correct, by sending a CURL request to my management cluster. And if I get a response that outputs the version of that cluster, it means everything is okay. And as you see on my screen, everything is indeed okay. I can see the major version, the minor version, and the rest of the information that we normally get when we query the Kubernetes cluster to find out the version. We can install Rancher Fleet through Helm, and you will see later that Rancher Fleet really likes Helm, even though we can use it to manage our resources, defined also as pure Kubernetes YAML or Kustomize. I think that those are the 3 supported formats, but Fleet itself likes a lot Helm, for good or bad. And to install Fleet controller on the management cluster, we need to install the CRDs first and then Fleet itself. And that's what I'm going to do by executing Helm upgrade, install, etc, etc, etc. And that's the installation of the CRDs, and I'm going to do more or less the same for the Fleet itself, you know, Helm upgrade, etc, etc. Let's move on. Let's see what else we should do. To be on the safe side, I will output the pods from the Fleet system namespace and just double check that everything looks fine, that all the pods are running, and indeed they are. I will also take a quick look at the logs and see whether everything is fine over there as well. And yes, everything looks peachy. So let's move on to the agents, onto the rest of the clusters. Actually, we cannot move to the rest of the clusters just yet. There are a couple of additional steps that we need to do in the management cluster. And the first one will be to create a namespace clusters. That's the namespace that we will use to manage all the clusters. So whatever we define there will be propagated throughout the rest of the clusters. You will see how that works later. For now, let me just create a new namespace called clusters in the management cluster. Next, we need to create a cluster registration token. That is the resource that will tell Fleet to create a token, and that token will be used to establish the communication between the management cluster and all the other clusters. So I will apply that resource, I will apply that definition, and as a result, Fleet created a secret. And we can see that it contains a couple of values. One of them is the certificate of the management cluster. Without it, we would not be able to authenticate agents to the management cluster. There is the address of the management cluster, so that agents know how to find the management cluster. The namespace, which in this case is clusters. And this is probably at the right moment to tell you that everything with Rancher Fleet is namespace. So we can have different namespaces with different permissions, so that different people can manage different clusters and so on and so forth. Today I will use only one namespace, so everything will be in the namespace called clusters. System registration namespace is the location where Fleet is running. And finally, we have the token that agents will use to authenticate with the management cluster. And now, finally, we are ready to move away from the management cluster into the agents. I will install those agents in each cluster separately with a relatively simple Helm upgrade install command. The only important thing here and throughout the rest of this review tutorial is that I'm always playing with kubeconfig, so depending on which cluster I want to use, I'm using one kubeconfig or another, so pay attention to --kubeconfig arguments because they are pointing to different clusters depending on what I want to do at any given moment. And in this case, I want to install the fleet agent inside of the development cluster, and I'm going to define a few labels for that cluster. And so this one in particular says that the provider is Civo, the cluster is CK, which is the type of the cluster in Civo provider, and the environment is set to dev. Finally, I'm passing that values.yaml file that contains all the information how that agent should connect to the management cluster. And if everything works as expected, I should be able to see a pod running inside the fleet system namespace in the development cluster, and indeed it's there. That's the pod. So everything looks fine, but just to be 100% sure, I'm going to output the logs as well and double check whether there is any funky business over there. Yep, and it looks fine, so we can move on. I still need to install Fleet Agent in 2 production clusters. So let's go through it fast. The commands are going to be exactly the same as for the development cluster, except that I will provide different labels. And the most important one is the label that says that the environment of that cluster is production. And then I will go to the second production cluster and execute the same command. The labels for provider and cluster are going to be different, but the environment is still production. So I'm labeling both of those clusters as production, and they should work together. Whatever is happening in one cluster, I want to happen in another, and vice versa. And now I'm going to go back to the management cluster and list all the clusters, and if everything worked, the management cluster should know that there are 3 additional clusters, and indeed there are. There's only one more setup step that I will perform. Inside the management cluster, I will create cluster group that will say, hey, there is this group of clusters that is called production, and you can find what those clusters are by matching labels. So whenever you see the label environment set to production, that cluster belongs to this group of clusters. Right now there are 2 clusters that match that label, but tomorrow we could have additional cluster, 3rd cluster, or 100 clusters with those labels, and they would automatically be picked up by Fleet and put into that group. And the reason for having such groups is to simplify the management of the resources in those clusters. We could tell Fleet, hey, this is the state I want in this cluster, which we will do later, or we could tell Fleet, hey, I want this desired state to become the actual state in all the clusters that belong to this group, no matter how many clusters I have there. Now, this is not particularly useful when having 2 production clusters like I have right now, but imagine that there are 200 of them. All that is left is to apply that definition, and now we are ready to explore Rancher Fleet from user's perspective. What we did so far was operational. How do we set up Rancher Fleet to operate across multiple clusters? And now we are going to start instructing it to monitor certain Git repositories and synchronize the desired state, what is in Git, with the actual state, which is across the fleet of clusters. We will go through different scenarios. The first one will be about synchronization with the local cluster. That's the management cluster. That's where Fleet controller is running. Then we are going to see how Fleet behaves when we instruct it to go and manage the state of a remote cluster. And finally, we're going to see how all that works when managing a group of clusters. So let's get going and explore the first scenario, the one with the local cluster, the cluster where Fleet controller is running. I already mentioned that Fleet can work with different formats for defining our applications. It works with pure Kubernetes YAML, Kustomize, and Helm. So we can pick any of the 3, and I will pick Kustomize, mostly because that's how I like to define internal applications, not necessarily third party, but internal. I like Kustomize, and hopefully everything that we learn through Kustomize should equally apply to Helm or pure Kubernetes YAML. We'll see whether that's really true, but right now let's see whether Fleet can manage my application defined in Kustomize format. In the repository where I am right now, among other things, I have a directory called Kustomize. Inside of that directory is a typical Kustomize structure. There is base subfolder with base manifests, and then there are overlays like production that contain everything that is specific to an environment. So this is no surprise. This is how vast majority of Kustomize definitions are organized. I am intentionally trying to go down the happy path. I might complicate it later. For now, let's see whether Fleet can manage Kustomize in a typical and fairly straightforward and basic form. So I have a Git repo definition. That's a definition that will tell Fleet what is the Git repository, where is it, what to do with it, and so on and so forth. The namespace is set to Fleet local. Namespaces are important with Fleet because each namespace in Fleet knows which clusters to manage, and Fleet local happens to be the default namespace that Fleet will use to synchronize with itself, with the cluster where Fleet controller is running. Then we are defining the repository, the branch, target namespace in the destination cluster, which just happens in this case to be the same cluster, and the paths. In this case, I have only one path that says, hey, the definitions, the manifests, in this case, Kustomize manifests, are stored in Kustomize overlays production directory inside of that repository and that specific branch. I do not need to instruct Fleet by telling it, hey, this is specific to Kustomize. Fleet will figure out that, hey, this is Kustomize because there is Kustomize YAML, or it could be a Helm chart if it finds some other files, or it could be pure Kubernetes YAML. In other words, Fleet is doing its best to figure out what is the format of the manifest that we are using. So all I have to do now is to apply that definition, and from there on, Fleet will manage the desired state of that cluster, of the local cluster, by making sure that the definitions over there are always the same as what is defined in a Git repository. So let's take a look at Fleet resources and see whether everything looks okay, whether everything looks fine. We have a cluster group that we defined earlier. It has nothing to do with what I'm trying to accomplish right now. And there is Git repo that says, hey, there are 0 out of 0 deployments ready. That sounds a bit fishy. That does not sound correct. It should have one deployment ready, the one defined in that repo that I just specified. There is something wrong, so let me describe the Git repo resource and see whether I can figure out what's wrong by looking at the events of that resource. And surprise, surprise, there are no events. I cannot see what repo tried to do, what it failed to do, why it's not doing what it's supposed to do, and so on and so forth. That's bad. That's really bad. I do not think that we should write all the events, everything happening, every single detail, but events should give us at least high-level overview of what is going on with some resource. That is not the case with Fleet, at least not right now, and that's disappointed. I am disappointed. But let's move on and see, to begin with, whether my application was deployed. Something should be running in the production namespace, and there is nothing. My disappointment is still there. I'm still disappointed, but I'm not going to give up. I'm going to take a look at the logs. Hopefully logs should give me a clue at what's going on. Why is my application not in that cluster? Why it's not up and running? And there we are. There's the culprit. There is an error and Fleet is continuously trying to fix it, but it cannot because it does not know what to do with relative paths. Kustomize.yaml file in the overlays production directory is referencing the base directory that is 2 directories back, and that's common, that's normal, but Fleet does not know what to do with it, and that's very disappointing. That makes Fleet useless when working with customized files, or at least useless to most of us who are using the typical structure to organize customized files. Now there is a way to fix it through fleet.yaml file, but that's cumbersome, that's silly. Fleet should do better than to force me to use workarounds, so I will not even go through those workarounds, and I will delete my application and switch to Helm instead of Kustomize, because hopefully Fleet works well with Helm. Here's a variation of the Git repo manifest that we explored before. The only difference is in the paths section. This time I'm referencing directory Helm that contains the Helm chart of my application so that we can see whether Helm works better. So I will apply that manifest and then I will retrieve Fleet resources from the Fleet local namespace. And this time it worked. We can see that 1 out of 1 deployments are running. It seems that this time Fleet knew what to do, how to do it, and the only tangible difference is that this time I am using Helm instead of Kustomize to define my application. To be on the safe side, I can retrieve all the resources from the production namespace and they're all there, my application is up and running, and I can live happily ever after. Now there is one very important thing to understand. Fleet does not apply your manifests as they are. If you have customized or pure Kubernetes YAML, it will convert them into Helm charts. So no matter what you define and how you define it, Fleet will convert that something into Helm charts and then apply those Helm charts to your cluster. So your applications will always be running as Helm charts inside your clusters. And that's different from how other tools tend to work, or to be more precise, that's different from other GitOps tools. Argo CD, for example, converts everything to pure Kubernetes manifests and applies them. So if you have a Helm chart in a Git repository, you will not have that chart in your Kubernetes cluster. And Fleet is the other way around. It converts everything, no matter the format, into Helm charts and then applies those Helm charts to your cluster. So let's see whether we can find something that makes Fleet special, that makes you want to adopt it. And that something special is in the way how Fleet manages deployments in remote clusters outside of the cluster where it is running. So let's explore how we can manage resources using Fleet in remote clusters. I will start with a single cluster, the development cluster that I created earlier, and then we will progress later on towards multiple clusters. Here's yet another variation of a Git repo manifest. This time the namespace is different. This resource will be created in the cluster's namespace because that's the namespace that was earlier configured to manage all the rest of the clusters I have. The second significant difference is that there is a new section called targets. There are 2 targets over there. The first one is called dev, and it has a cluster selector with a single matching label that says that environment or env should be dev. As a result, Fleet will manage applications in all the clusters that have that specific label, which in my case is a single cluster, the development cluster. And the second entry in the target section is something that I will not explain right now. We're going to get to that later. So imagine that it doesn't exist. Let your brain forget that you ever saw the second target, and I will let you know when that target becomes significant or important later. For now, we're focusing on the scenario where we want to manage applications, manage resources, Kubernetes resources in a single remote cluster, and that cluster is the one that was registered with the label environment set to dev. So I'm going to apply that manifest, and then I'm going to retrieve all the Fleet resources from the cluster's namespace, and we can see that 3 out of 3 bundled deployments are ready. I will explain later why there is 3 and not 1, because for now we're focusing on the dev cluster. So let's confirm whether the application is indeed running in that remote cluster by using kubeconfig of that cluster and listing all the resources in the default namespace. As expected, the application is now running in that cluster as well. So we have the application confirmed to be running in 2 clusters, in the local cluster and now in the remote cluster, in the dev cluster. It's running in other clusters as well, but that's for later. The important part of every GitOps tool is automated drift detection and reconciliation. And by today's standards, That means that the actual state should always reflect the desired state, with actual state being state in a cluster or multiple clusters, and the desired state being what is stored in Git. If there is any deviation between those two states, or we call it drift, if there is any drift between those, the tool should detect the drift and reconcile it so that those two states are almost always the same. That shouldn't be happening only when we make changes to Git, but always, always, always. So I'm going to do a small experiment. I'm going to change the actual state of the deployment manually, and the expectation is that Fleet will detect that somebody messed up the actual state and undo my changes. That's what Argo CD is doing, that's what Flux is doing, and that's what I expect Fleet to do as well. So here we go. I'm going to edit the deployment, and I'm going to change the tag of the image from 2.7.0 to 4.0.0. I'm changing the state of that deployment to be different than the desired state defined as Git. That should be unacceptable. Fleet should undo those changes shortly afterwards. So let me save the changes and describe the deployment. If the tag of the image is 4.0.0, Fleet did nothing, and that's not good. That's not what I expected to do. So let's see what we'll get. And this is disappointing. Fleet did nothing. It did not detect the drift, and if it did nothing to reconcile it. It is probably waiting for me to commit changes to Git. But that's not what I want, because then I wouldn't need GitOps tools. I could accomplish the same results through pipelines. You know, Jenkins or CircleCI or Tekton or Argo workflows. And then at one moment in a pipeline, you have a command like kubectl this and that, or Helm this and that, and so on and so forth. One of the main reasons why we are adopting GitOps tools is because they have continuous drift detection and reconciliation. Now, I might have been hasty, so I will go and fetch coffee, and when I come back, I'm going to describe the deployment again, and if Fleet did not revert my manual changes, I'm going to be very disappointed. So this is me going for a coffee and coming back in a few minutes. Okay, so let's see what happened. Let me describe that deployment and hope for the best. I really want this to work. Nope, it's still 4.0.0. I'm very disappointed, and I hope that this is not the conscious decision, that this is some sort of a bug or something like that. So this is the message to the Fleet team. Please, 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 please fix this. This cannot be a conscious decision. This cannot be happening. You need to have continuous drift detection and reconciliation, and do not wait for me to push some changes to Git until the states are reconciled. Please, please, please fix this. Now let's go to the real deal. Let's explore the real strength of Fleet. Let's see how we can manage deployments, how we can synchronize states across multiple clusters. As a refresher, let me show you the Git repo manifest that we already applied. Specifically, I want to talk about the second target, the one called production, that says, hey, there is a cluster group called production. And this has a couple of implications. It means that we have a single place where we can define all the targets, all the destinations. And the first target says, hey, I want this application to run in the dev cluster. And the second target says, I want this application to run in all the clusters that are inside of the group called production. And that simplifies management of our applications greatly. This is much easier than the model behind the tools like Argo CD. Typically in Argo CD, we would need to define an application for each environment, but that's actually not true. We could use application sets with Argo CD, which would give us more or less the same result as this one. But then there is something else that I need to show you, something that makes this really special and unique. But I will get to that thing later. I need a couple of more minutes, because first I want to confirm that this application is already running in all the clusters within the production group, which in this specific case means 2 clusters, production 1 and production 2. So let me list all the resources from those clusters, or to be more precise, all the resources in those clusters that are within the default namespace, because that's where I instructed Fleet to deploy them. So let's go. Let's see what's in production cluster 1. And the resources are there, so my application is running in production 1. Let's list all the resources from the cluster production 2, and the resources are there. So this is amazing. My application is already running in multiple clusters, and that was fairly easy and straightforward to do. I defined only one Git repo manifest. I specified all the targets for all the clusters or groups of clusters that I want that application to run in, and Fleet did the work. But that Git repo manifest alone cannot be the solution, because I do not want to run the same releases of all the applications in all the clusters. I might have one release in the development cluster and another release in staging and third release in production, and those different environments might have different variations, different variables, different number of soft replicas, and so on and so forth. What I'm really trying to say is that I cannot let Fleet just run identical copies of all my applications everywhere. I need to have a way to specify what are the differences between different environments, between different clusters, and I can do just that through a file fleet YAML that should be stored in the root of the directory where the rest of the definitions of my application are. So let me show you that file. Let's see what's inside. So there we are. This is the file that allows us to specify variations of the applications running in different environments, in different clusters. There is a common section that in this case is very simple. It says, hey, this is where the chart is. You could have many other options. And then we have target customizations. Those are the customizations that will be applied to the application depending on the specific target. And target can be a cluster or a group of clusters. So when deploying to something called dev, I want to overwrite one of the values. I want to explicitly set image tag to be 2.7.0, and those customizations should be applied to all the clusters which have the matching label env set to dev. And the second customization is almost the same as the first one, at least for now. I'm going to change that soon. It specifies the same image tag as the value, and the difference is in the cluster selector that says that the matching labels should be env production. So this should apply to all the clusters that have the label env set to production. According to that specification, release 2.7.0 should be running in all the clusters. Now let's say that for whatever reasons we want to run a different release in production. We want production clusters to be different from the other clusters, and that difference will be, in this case, in the tag. So I'm going to edit that file and change the tag of the production customization to be 4.0.0. Then I'm going to add and commit and push that file back to Git. And I'm going to describe the deployment of that application in one of the production clusters in production 1. And the tag is still 2.7.0. Now this is building towards being yet another disappointment, but that's not the case. I was just too hasty. I was too fast. I did not give Fleet enough time to detect that I made changes to that Git repo. So let's describe that deployment one more time. And it worked. We can see that the image of the application running in production is now 4.0.0. And that's fantastic, not only for the obvious reason, meaning that it works, but also because this is what gives Fleet the edge. And we're going to talk about that edge soon. We are about to go into the next section and talk about pros and cons in general and come to some conclusion whether you should or shouldn't use Rancher Fleet. So, what should we start with? Should we go through pros or cons? Let's go through cons first. Let's see what are the things I do not like, the things that do not necessarily work very well. To begin with, Fleet is very new and very green. It is a project that started recently and that did not have as much time to mature as Argo CD or Flux. And that's not necessarily a bad thing, because all we need to do is wait for a while longer until there are a couple of more releases of the project. I'm always very interested in potential potential of the projects, because that gives me idea where the industry is, where it goes, and what I should adopt now or what I should wait for, and so on and so forth. The second problem is that events are conspicuously missing from the resources. My first step in debugging issues is always to describe the resource, see the events, and then go through logs and all the other sources of information that I might have. Fleet events are non-existing basically, and that's not good. That's not good at all. It works with Kustomize, but not if it has relative paths, and that's the common pattern in Kustomize, so that's another thing that does not really work. And if you dive deeper in Fleet, it's obvious why. Fleet is Helm first, everything else second, so it wants to support Kustomize, but it's probably not very high on the list of priorities. I mean, it does support Kustomize, but not really very well. What's next? Oh yeah, fourth thing is that it is not really feature rich. It is not as big and huge and powerful and feature rich as Argo CD and Flux. And again, that's normal because it's a much younger project. It did not have enough time to build all those features. And by the way, you probably do not need many of the features that other tools have. So one tool having more features than the other does not necessarily mean that that tool is better. What does matter is whether you do need those features or no. Fleet covers the most important use cases, and all the additional features that other tools have are more like a bonus unless you really need them, and then they're not one. Anyways, Fleet is not as feature rich as other tools, but that does not necessarily mean that it's a worse tool than other tools. And finally, there is no continuous drift detection and reconciliation, and that's probably the biggest problem I have with Fleet right now. That's one of the main principles of GitOps. Continuous drift detection and reconciliation, which Fleet does not have. Or it is not enabled by default. Maybe it is hidden in some parameter, in some argument somewhere, but if that's the case, it should be default. That's the default behavior. That's what we want by default, simply because that's one of the main principles of GitOps. Continuous drift detection and reconciliation, independent of commits to a Git repository. Now I will tell you to discard all those negative things, to discard all the bad things I said about Fleet, because it's a new project. For now, I will attribute all those to Fleet being much younger project than others. I expect those and other issues to be fixed in upcoming months, and by the time you're watching the video, maybe they're already gone. Maybe you're thinking that I'm going insane because you're not seeing the same issues, and if that's the case, then great. Fleet is on the right path because the benefits of Fleet are huge. They're massive if you're running at scale, if you have many clusters, because that's the main focus of Fleet. It is designed to run at scale. It was designed from day one to manage resources on many clusters. And we can see that both in the way how it behaves, how it is installed, and its API. The manifests we use to instruct Fleet what to do and how to do it and where to do it were clearly designed for scale. When running at scale, when having tens or hundreds or thousands of clusters, Fleet is much easier to manage, among other reasons because the manifest, the API, is designed for that. Fleet YAML file that sits in the same place as the manifest of our applications is absolutely brilliant. It allows us to customize our applications based on labels or groups matching one or many different clusters, and it's absolutely brilliant. The resource and the API in the manifest was clearly designed to provide one-to-many relation. There is one repository and many clusters. And that's very different from the initial design and the main focus of Argo CD and Flux. That is not to say that we cannot use Argo CD and Flux to manage applications at scale on many different clusters, but that Fleet was clearly designed with that in mind from day zero, while other tools are trying to put that as almost a secondary thought. And now comes the important question. Should you switch from Argo CD or Flux to Fleet? And the short answer is not yet, but probably, potentially in the near future, sometimes in 2022, and only and exclusively if you have many clusters, if you want to manage resources at scale. If you're talking about small number of clusters, then Argo CD and Flux are clearly a better choice, but for a massive number of clusters, Fleet could be the solution, but not today. Right now you should play with it, you should evaluate it, but wait for a while longer.